So let's think about the following question. And of course, you might have some trouble remembering the vertex form. What's the vertex form? Does anyone remember? A x minus h squared plus k. Right? And in this formula, what is h comma k? This is the vertex, right? Okay. Do you also know the formula for h? How do you get the h?
b over 2a.
Negative b over 2a. Okay. And this comes from the quadratic formula, right? It's x equals to negative b plus or minus, that part is gone, and it's just all over 2a. Right? The plus minus square root part is gone. Okay? That's how you think about this. There's a reason for that, which I explained earlier, but let's think it as that. All right. Now, how do you find k then? If you know the x-coordinate of the vertex, how do you know the y-coordinate of the vertex if it's on a graph? And any time you know the x-coordinate, you can find the y-coordinate by plugging in the value into the function. Right? So if I call this function f, if you evaluate this function at h, you get the k. So let's follow that plan. We take h as negative b. What's b here? Negative 10. You have to include the sign. Over 2 times 1. Because x squared has no coefficient. That means that it's 1 times x squared. That's how you think about it. And then negative cancel, so you get 10 over 2, which is equal to 5. That is going to be your h. And your k now is you plug this into the function to evaluate. So let's see, 5 squared minus 10 times 5 plus 1. 5 squared is 25 minus 50 plus 1, which is negative 24. And then you can write down the vertex form. It's a times x minus h. But what's a again? A is 1. So you don't write. If it's 1 times something, it's same as not writing anything. So you don't have to write 1 here. X minus 5, because that's your h. Remember, it's a times x minus 5. And k is negative 24, so we put minus 24. That's the vertex form. All right. It also said to find the intercept, so let's find the intercept. First, the y-intercept is obtained by plugging in x equal to 0 there. So y-intercept would be 0 squared minus 10 times 0 plus 1, which gives you 1 as your y-intercept. On the other hand, the x-intercept is you set y as 0 and you have to solve this quadratic equation. But if you already have the vertex form, it's easier to solve the equation in the vertex form than the original standard form, okay? So let's use this one. We're going to set y as 0, so 0 is equal to x minus 5 squared minus 24. Add 24 both sides. And then you take the square root. So what is x minus 5 equal to?
Negative.
Plus or minus square root of 24. Another thing is, anytime you see, yes?
So, will we have to, like, do that? You remember how you taught us, like, when you have the square root of something like 24, right? 2 and then square root.
Yes, you have to bring the 2 outside.
Right.
That was what I was about to say. 24 is, it has a square factor, right? What's a square factor in 24? Does it have 2 squared as a factor? 2 squared is 4. 4 times what is 24? 6. So 4 is indeed a square factor. So once you write this 24 as 4 times 6, this 4 can come outside the square root as what? 2. And we're almost there. We still have to solve this x. To isolate x, you have to get rid of this 5. You add 5 both sides, and you get x equals to 5 plus minus 2 square root of 6. Okay. Now let's try to draw this. First, you want to make sure that you're at the correct vertex. So let's see, 1, 2, 3, 4, 5. Let's say this is 5. And negative 24 is all the way down here. I'm just guessing. So this is your vertex, right? And to draw the graph of a quadratic, you really just need the vertex and the y-intercept. Y-intercept is 1. That's what we want. We have, right? So you can draw a curve that has the bottom at the vertex and comes back up. That's that. So that will be the graph of this equation. And we know the values of this. See, you have 5 minus 2 radical 6 and 5 plus 2 radical 6. Of course, the one with the plus will be on the right side. So this point will be 5 plus 2 square root of 6. And this point here would be 5 minus 2 square root of 6. And that's it. That solves the question. Now, the purpose of this question was twofold. One is to make sure that you know how to do this. It's a good review. But I also want to show you a second way of obtaining this vertex form, which is called the completing the square. Let me talk about completing the square. So the original equation was y equals to x squared minus 10x plus 1. And what I'm about to show you is the easiest case for completing the square. Completing the square can become quite complicated, and if you have all these other cases where you have some strange coefficient in front, and if this is odd and all that, it does become very hard. So I don't want to touch that. That's not required for you to know, at least for this class. I only want everyone to know the simplest case where the x squared has coefficient 1 and the coefficient in front of x is an even number. Okay? You don't have to worry about the odd case. That's harder. Okay, so how do I deal with such a thing? What do I mean by completing the square? It's just two steps. One is you take this middle number, right? You take half of that and put it inside the square. Okay, that's step one. So let me do this. Take half. Okay? Take half of that. And now you have to think about what goes in here. So that's the second step. So the first step's really easy. Just take half of this number, put it inside the square. The second part is, this is the hard part, but it's not that hard. It's simply this question. If you expanded this out, it's going to create x squared. It's going to, you have to double the product thingy that creates negative 10x when you expand it by FOIL. But then when negative 5 is squared, it's going to give you 25, right? That doesn't agree with 1. So that 25 plus something should match with this 1. Do you agree? Okay. So now the question is, 25 plus what gives me this 1? Negative 5 squared gives you this 25. So let me, this is going to create this 25. And now the question is, this plus what gives you this 1? Which is this one.
Negative 24. Negative 24.
Yeah. So you see that negative 24 is the one that makes this equation true, right? So that's why you put negative 24. And that's it. Yeah, I'll just put negative 24. That's it. Negative 24. And this is going to be exactly the same as this. Notice that this is exactly the same as this answer we got, right? But with less work, right? Well, before we had to find h, and we had to plug it back into the equation to get the negative 24. But here it's just almost immediate. So you should find this easier than our previous method. Is it okay? All right.
Now would that be would be written though as plus negative 24, or would that what side?
Oh, you can just write down as negative, just x minus 5 squared minus 24.
That's what I thought.
Yeah. And by the way, you should also check that this indeed is equal to the original thing. I mean, you know, during the exam, let's say you've solved everything and you have some time left and you want to check if you got things right. And you come back to this one and you want to know if you really did this correctly or not. How would you check? Well, think of it this way. Write down x minus 5 squared as x minus 5 times x minus 5 minus 24. And x times x is x squared. X times negative 5 is negative 5x. Negative 5x is again negative 5x. Negative 5 times negative 5 is positive 25. Remember, negative times negative is positive. And you still have negative 24. And then look at this. These are like terms. What's negative 5x plus negative 5x? What do you get? Negative 10x, right? And then what's 25 minus 24? 1 plus 1, which is exactly what you started with, right? So you can check your answer like this.